Namaskar. Today we are going to deal with the topic silk degumming. A major undesirable constituent part of silk is the silk gum, also called as sericin, which is about 25% of the total mass. Sericin is removed by degumming. Degumming is the process of removing sericin or the silk gum from the silk. Removing the gum improves the sheen, color, hand and texture of the silk. As a protective layer, it is typically left on the silk until it is ready to dye. In some cases, the fabric is woven to completion and then degummed to protect the yarn from abrasion on the loom. The process involved to remove these impurities is called degumming or scoring of silk. As we see the composition of the raw silk, it is as follows. The silk is composed of 70 to 80% of fibroin and 20 to 30.5% of sericin and 0.4 to 0.8% of waxy matter and 1.2 to 1.65% of carbohydrates and inorganic component of 0.7% and pigment of 0.2%. The process of eliminating gum, the silk gum from the raw silk is called as degumming of silk. Degumming of silk involves mainly the removal of sericin from the fibroin. Sericin is insoluble in water. It is comparatively easily hydrolyzed, whereby the long protein molecules of the sericin is broken down into small fractions which is easily dispersed and solubilized in hot water. The animal protein or protein fibers are very irregular in composition. They contain a significant amount of non-fibrous impurities of about 50% in case of wool and 15 to 30% in case of silk. These fibers are very sensitive to alkali and are damaged quickly on wet treatment at high temperatures, especially the wool. Hence, these fabrics are scored with large amount of soap and detergent, with little or without alkali at low temperatures. As we see the degumming of silk, the silk filament chemically is a monofilament of protein extruded by the silkworm called the bave, consists of two brins. These two brins are stuck together by sericin and become a single continuous filament. Thus, the silk wave is a two brin held together by sericin. As we see the typical recipe for silk degumming, it has the following components with the composition as wetting agent of 0.5 to 1 gram per liter, sequestering agent 1 to 2 grams per liter, anti-foaming agent 0.5 to 1 gram per liter and natural soap 15 to 30 grams per liter, TSP or soda ash 1 to 3 grams per liter and detergent 1 to 3 grams per liter. This detergent is a non-mandatory constituent if we use soda, and it should be run at a temperature of 90 to 95 degrees centigrade with a duration of 90 to 120 minutes, and a pH should be maintained at 9.5 to 10.5 pH, and the liquid material ratio should be maintained at 10:1 composition for the typical degumming bath. As we see, the process of eliminating the gum from the raw silk is known as the degumming of silk. Degumming of silk involves mainly the removal of sericin from the fibroin. Sericin is insoluble in water. It is comparatively and easily hydrolyzed, whereby the long protein molecule of sericin is broken down into smaller fractions which are easily dispersed or solubilized in hot water. Hydrolysis of protein can be carried out by Treatments with acids, alkalis and enzymes. Acids are non-specific and tend to attack vigorously. Alkalis also attack both sericin and fibrin. However, the variation in the rate of hydrolysis is large enough to control the reaction. The degumming with soaps in the presence of mild alkalis like soda ash is in practice. Degumming with alkalis is a function of pH and temperature and duration of the treatment. The pH should be kept at a level of 9.5 to 10.5 all through the reaction. If the level is below 9.5, then the process of removing sericin will be slow. If the pH is over 10.5, the degumming loss will be greatly increased. As we see the process, the degumming of raw silk is generally carried out using 4 to 5 grams of per liter soap and 1 gram per liter soda ash at a boiling temperature for 5 to 60 minutes, maintaining liquor ratio at 30:1. The treated materials given a hot wash for 10 to 15 minutes, and finally it is washed in the cold water. The degumming process, which removes the silkworm, is also called as boiling off process, and this is accomplished by the use of soap and soda. The degumming loss in this process is 20 to 25%. In certain cases, entire silkworm is not removed, but only sufficient amount is removed to make the silk soft and lustrous and workable in dyeing and bleaching. This is known as soapling, in which only 10 to 15% of the gum is removed. The process of scoopling. Raw silk is soaked in lukewarm dilute soap bath for several hours and rinsed in fresh water. After scoopling, the silk may be bleached or dyed. After bleaching, the scooped silk is frequently given a treatment with hot solution of tartar at 85 degrees centigrade. This causes the silk gum remaining on the fiber to soften and remain in that condition permanently. In addition to removing the soil or additives used while weaving the silk, scoring removes any sericin that remains on the silk. Often the quantity of the natural gum has been allowed to remain on the silk fiber to give it additional body and to make it easier to handle in spinning and weaving. Although the raw silk fabrics, the gum is retained purposely to provide body or produce a different texture. Most silk fabrics are degummed as a part of finishing process. The resultant fabric has a much softer hand and a wider appearance. Silk is widely bleached with dilute solutions of hydrogen peroxide. Raw silk is sometimes given a very mild scoring for the purpose of softening the texture. This is called ecru silk, in which only 2 to 5% of the silk gum is removed. Ecru silk can be prepared by simply washing the raw silk in lukewarm or hot water without use of any soap. This is used mainly for warp, hence the gum is left purposely. The degumming of silk fabric is generally carried out batch-wise in small lots using equipments as follows. Open back. Most common used equipment in degumming is open back method. The fabric is evenly piled in the open vessel, filled with the degumming liquor and treated from the bottom. In case of fabrics containing small quantities of sericin, the treatment in the open back may be quite effective. Star machine used for degumming of delicate fabrics and cases where the primary consideration is perfect production quality, especially for the goods which are to be plain dyed. The assessment of effectiveness of degumming is done by the extent of removal of sericin by calculation the weight of loss of fabric after degumming, scanning through the electron microscope or by chemical staining method. Bleaching of silk. The silk being spun by the silkworm contains natural coloring matter tinted with yellow, yellow green and brown pigments. During degumming, the removal of sericin from the silk results in the dull white to lightly tinted material. Since some of the sericin is closely held by the fibroin, complete elimination of the color by the degumming is not possible. During bleaching, these natural coloring matters are decolorized or removed to produce pure white material. An efficient bleaching process must ensure pure and permanent whiteness. Levels of dyeing properties and non-degradation of the materials are also depending on this bleaching process. The bleaching of the silk is based on the use of either reducing agents or oxidizing agents. Some of the important reducing agents used in the bleaching are sodium hydrosulfide, sulfur dioxide, sodium sulfoxylate formaldehyde, zinc sulfoxylate formaldehyde. The above reducing agents at time tend to reoxidize original colors may be restored in the bleaching material. The popular oxidizing agents used for the bleaching are hydrogen peroxide, potassium permanganate, sodium perborate and sodium peroxidase. The chlorine based agents such as bleaching powder, sodium hypochlorite are not generally used as they tend to chlorinate the silk fibroin. Of the above, hydrogen peroxide is mostly preferred. As we see the methods of bleaching, this is done with sodium hydrosulfide, which is also called as hydrose. The degummed silk goods are treated in a bath containing 4 grams per liter of sodium hydrosulfide at 50 degrees for about 4 to 6 hours. The entire lot must be completely immersed and the bleaching liquid is stirred sufficiently to ensure uniform distribution. Finally, the material is thoroughly washed. It is noted that solution should be made up only when required as its reducing power deteriorates rapidly on storage. As we see the process with sulfur dioxide or sulfurous acid, the degummed silk goods are hung in a suitable chamber where they are exposed to sulfur dioxide gas or immersed in sodium bisulfate in water for 4 to 6 hours. Approximately 5 kg of sulfur is required to bleach 100 kg of the silk. This method of bleaching is not generally practiced as it causes air pollution. Bleaching with sulfoxylate. Sodium sulfoxylate formaldehyde is a stable reducing agent marketed as rangolite, sulfolite, etc. A bath containing 2 to 4% of sodium hydroxy sulfoxy formaldehyde and 1 to 2.5% formic acid is prepared. The goods are treated at boil for 20 to 30 minutes. Finally, the material is thoroughly washed. Zinc sulfoxylate formaldehyde, also known as edicoline, sapholine, can also be used as bleaching agent. As we see the process of bleaching with sodium peroxidase, in this process, bleaching is done in the following typical recipe: sodium peroxidase 2 to 4%, magnesium sulfate 0.5%, sodium silicate 3%, sulfuric acid 2 to 4%, sodium bicarbonate 0.5%, material is to water is 1:30 ratio with a duration of 4 to 5 hours at 60 degrees centigrade. The oxygen yielded by the decomposition of sodium peroxidase oxidizes the chromogens of silk so that it becomes colorless. As we see the bleaching with hydrogen peroxide is the most preferred bleaching agent, which is sold as 35 to 50% aqueous solution. It is quite stable under acidic conditions too. The typical recipe for peroxidase bleaching process is given below. Silk goods dash cages, material is to water 1:30, H2O2 6 grams per liter, sodium silicate 1.5 grams per liter, soda ash 0.5 grams per liter with a temperature of 80 to 85 degrees centigrade with a duration of 60 to 90 degrees centigrade. In this process, the liberation of peroxy ions act as a true bleaching agent. Here, the sodium silicate acts as a stabilizing agent and helps to maintain the speed of the process slowly and steady. The hydrogen peroxide is used as an important agent for silk as the white color generated lasts long and further it possesses a good stability and storage. As we see the optical bleaching methods, in order to achieve the required degree of whiteness of a fabric, color complementaries are introduced to achieve desired luster. To obtain this, the material is treated with an optical brightening agent. The chemicals behind this is that these agents absorb invisible UV light and emit the visible range of spectrum. Some of the commercial available agents are ranipal, leucofer, PAT, etc. As we see a typical recipe for this, 0.5% of ranipal, 2 grams per liter sodium hydrosulfide, and the material is to liquid ratio should be 1:30. A material is immersed in the above bath at 60 degrees centigrade and treated for 30 to 60 minutes. Finally, the goods are washed and dried. Methods of soap degumming. Silk hands are prepared and weighed accurately after drying into oven for 1 hour at 110 degrees centigrade. They were then boiled for 30 minutes in a solution consisting of sodium stearate 6 grams, soap flakes and water 600 ml. Solution was then poured off and fibers are boiled for another 30 minutes in fresh soap solution. Solution was then poured off and remaining fibroin fibers were washed with 5 separate quantities 200 ml each of the distilled water to remove soap and sericin. Excess water was removed by filter paper and fibers were dried for 1 hour at 110 degrees centigrade prior to weighing. Quantity of removed sericin expressed in percentage was obtained using the formula S equals to B minus A by B into 100%, where S is the amount of removed sericin, B is the mass of fibers before degumming and A is the mass of fibers after degumming. Methods of enzymatic degumming. Silk fibers were prepared and weighed according to the procedure described in here. Subsequent degumming process was carried out in a solution consisting of alkalis 2 to 5 liters and other auxiliary agents. Contents of enzyme degumming bath and process parameters are shown here in table 1. After degumming, samples were washed with 5 separate quantities 200 ml each of the distilled water. Excess water was removed by the filter paper and the fibers were dried for 1 hour at 110 degrees centigrade prior to weighing. As we see the table 1, that gives the constituents of the enzyme degumming bath and process parameters. Table 1. The contents of enzyme degumming bath and process parameters. Alkalis 2.5 liters to 1 gram per liter, then NaHCO3 5 grams per liter, non-ionic surfactant 1 gram per liter, temperature 60 degrees, time 60 minutes, pH 9 and liquor ratio, material is to liquor ratio is 1:30. For inactivation, the temperature is 80 degrees centigrade and time is 20 minutes.